Good afternoon once again, fellow scholars. It is I, Chris Crowe, and today I'm going to be taking you through Module 2, Chapter 9, Geometric Figures. And without further ado, let's get into the video. So here we see question 1, which asks us, using lines 1 and 2, explaining to us that they are parallel. It wants us to demonstrate the relationships between the measures of angles 1 through angle 12. Create a chart to show similar, complementary, and supplementary angles. Now, as you can see here, we're going to fill out this graph that I've created with the different angles. You can see lines 1 and 2 there, and they are, in fact, parallel. And so we also have these two angles, 61 and 63, in the middle triangle, respectively. So moving forward, we are first going to explain that a triangle angle, all the angles in a triangle will always equal 180 degrees when added together. So that is how we can actually go about figuring out angle 7, which is the most immediate one that we can figure out, because it already has two of the angles that we need in order to figure out angle 7, the third angle. So we're simply going to add 61 and 63 together, and that gives us 124. And then when you have that number, you have to subtract it from 180, because that is the number that all angles are equal to. And so through that process, we are given 56. So angle 7 is going to equal 56 degrees. Now, the order of these angles would be slightly out of order and when we figure them, because we have to jump around just a tad. So we are actually going to skip to figuring out angle number 3. And we can see angle number 3 is 61 degrees. Now why is that? Well, the answer is actually quite simple. If you look at the graph here, you can see, or the figure more likely, angle 3 and the angle that says 61 degrees are the exact same angle. Those are what are known as corresponding angles. Corresponding angles specifically are angles that are the same, created by one line. You can see here the one line, we don't have a name for that one, but it is creating both of those angles, so they're the same ones. So angle 3 is going to be 61 degrees. Moving forward, angle 1 is 56 degrees, the same way as angle 7. Now why is that? The same reason as angle 3 is 61 degrees alongside the already named 61 degrees, because of the fact that they are corresponding angles. One line is creating both of them going diagonally to the left side. Moving on, we have angle 4, which is 61 degrees. And the reason that angle 4 is 61 degrees is because of the fact that angle 4 and angle 3 are opposite vertical angles. And what that means is that they are the same angle, they're simply opposite of each other. So 3 is 61 degrees. So angle 4 is opposite but equal. Therefore, it is also 61 degrees. Angle 2 follows the same pattern, except it is opposite and equal to the 63 degree angle that we used in our first triangle to figure out angle 7. So angle 2 is 63 degrees. Angle 5 follows the same pattern as the last few that we've covered, except it is opposite and equal to angle 1, which you already know is 56 degrees. So angle 5 is 56 degrees. Now moving on to angle 6, we actually have to look at it differently, because it's not like the previous angles. Angle 6 is actually a supplementary angle, and what that means is that its sum is 180 degrees. So here we see angle 6 is unnamed, but the 61 degree angle is actually next to it. So we have to actually subtract 61 from 180 because of the fact that its sum is 180. So, 180 minus 61 is 119. So that means that angle 6 is going to be 119 degrees. We've already figured out angle 7, so we're going to move on to angle 8. And that will be handled the same way as angle 6 was, because it is also a supplementary angle. So instead of subtracting, in this case, 61, like we did in the previous, we're going to subtract 56 because of the fact that we already know angle 7. So angle 8 will be 124 degrees after subtracting 56 from 180. Now, moving on to angle 9, the reason it is 61, the same reasons as the first couple. It is an opposite equal angle to the 61-degree angle from the original triangle, so it's going to repeat that same pattern. Angle 10 will repeat the same pattern as that. It is an opposite equal angle to number 6, so therefore it is also going to be 119 degrees. Now, figuring out angle 11, again, is the same way. It is going to be opposite equal to angle 8. So it's also going to be 124 degrees. And of course, angle 12 is 56 degrees because it is opposite and equal to angle 7. Now, moving on to number 2. We have to demonstrate how to find measures of angles 1, 2, 3, 4, 5, 6, 7, and 8. We need to create a chart to show similar complementary and supplementary angles the same way we did the first one. Only this time we are working with a triangle that has been split into 3 smaller shapes. However, if you were paying attention in question 1, this should not be difficult. So moving forward, we have 74 plus 26 equals what to equal 180? And it gives us the answer, angle 1 is equal to 80 degrees. Why is that? Well, if you're looking at the entire triangle, not the individual shapes inside them, but the entire triangle, you have your 3 angles, or rather the 2 with the third that needs to be figured out. We have 74 and 26. And so we need to add those together, and then whatever that number is, we subtract it from 180. In this case, it gives us 80 for angle 1. And so from there, we can simply move forward in figuring out the other angles. In this case, we see angle 2 is 100 degrees. Again, why? Because it's a supplementary angle. It needs to have 180 minus 80 in this case. And the reason being is because the sum of the angle is supposed to be 180. So 180 minus 80 is going to be 100. So angle 2 is 100. Angle 3 is going to be 80. Why? For the same reason as some of the previous angles in the previous question. Angle 3 is a corresponding angle to angle 1. They're the same angle created by one line. So it is going to be 80 just like angle 1. Now we have angle 4 equals 26 degrees. Now why is that? You might think that since you now know angle 3 and you already have point C's angle, 74, you can just do the same trick you did with the original. You wouldn't be wrong to think that, but you would be wrong in doing so because that is actually more complex than what you need to do to get the correct answer. If you look down at point B, the bottom right of the triangle, you can see 26 degrees. Now, angle 4 and angle 26 degrees, or point B, are the same angle. They are a corresponding angle. So, of course, angle 4 is going to be 26 degrees, the same way that point B is. Moving forward, we have angle 5 is equal to 80, because it is an opposite equal angle to, you guessed it, number 1. And if you were to check, you would also see that it is the exact same angle as number 3, simply opposite but equal. Angle 6 is actually 74 degrees. And the reason behind that is because, looking again, angle 6 and point C, 74 degrees, are no different from each other. They have the exact same angle. If you were to fit one triangle into the other, perfect match. Angle 7, we see, is 100 degrees. Now, the reason being is because we simply had to figure out the supplementary of it. The entire sum is going to be 180. So it's the similar trick to finding out some of our previous angles. And finally, angle 8 is 80. Again, because you can easily figure most of these out by simply looking at the other angles. It's more along the lines of common sense than any super secretive method to figure them out. Okay, so now moving on to question 3. We have to demonstrate how to find the measures in the concave polygon. Now, here is an admittedly scary looking shape, but the method to figure out the measures of the angles in the concave polygon is actually quite simple. So here we're going to use the formula n minus 2 times 180. Now what is n, you might be thinking? Well, that's actually the amount of points that are on the shape. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 points. So now we are going to replace n with 8. So 8 minus 2 times 180 is going to equal 1080. And so now we are going to take all of the numbers that are inside this concave polygon. So 3y plus 3y plus 3y plus 3y plus 7y plus 7y plus 7y plus 12y plus 12y. You can see there, it happened. And so we're going to equal that to 1080. And then what we're going to do is marginally simple algebra. We're going to add all of them together. They are like terms, so the y will remain. That will give us 54y. We're going to equal that to 1080, and then we will divide both sides by 54y. 54 takes itself out, and so we are left with y equals 20. And so from this point forward, we are simply going to replace 20 with, we're going to simply multiply 3 times 20. And the reason we're doing that is because of the interior concave angles. See, all of them are exactly the same as the others so long as they have the same number. 7y, 3y, 12y, the corresponding, they are all the same angle. So, with that in mind, angle 3 will become 60 degrees. Angle 7 will become 140 degrees. And angle 12 will become 240 degrees. And this can be made slightly easier if you remember the difference between obtuse and acute angles. Acute are less than 90 degrees. Obtuse are more than 90 degrees. And a right angle is exactly 90 degrees. So if it appears to be 1 and you think you have the correct answer, remember that just in case you're doubting yourself. So now we're going to move on to question 4. We have to demonstrate how to find the measures of the interior, exterior, and central angles of the n-gon. Now the n-gon is going to represent a shape with a somewhat indeterminate amount of sides, hence n. Now with this particular instance, you can count the sides, but it is n-gon, so it cannot be fully determined or explained because it can be applied to any number of faces within a shape. So in this instance, the interior angle formula is similar to the one that we just used. It's n minus 2 times 180 over whatever number n is going to represent. And then the exterior and central angle formulas are actually one and the same, which is 360 divided by n. So in this case, we are going to see that n is equal to 9 because there are 9 sides around this shape. Even though we said an n-gon, in this case we can actually determine the number of sides for the sake of finding our answer. And you should be able to use these formulas to figure out the process. It is not difficult. Given here, we see the interior angles will come out to 140 degrees. The exterior angles will come out to 40 degrees. And the central angle will come out to 40 degrees. Now, moving forward with question 5. we have to construct vertices D, E, G, and H, which are the vertices of a tetrahedron inscribed inside cube A, B, C, D, E, F, G, which I will bring on screen in just a moment. Construct 3 of the faces of the tetrahedron D, E, G, H as subsets of the faces of the cube. So this is a 2-part question. So here we have our tetrahedron. We have A, B, C, D, E, F, G, H. And so now that we've constructed that particular figure, we now have to create the subsets. And what this is asking for, it is asking, sorry, that is our cube, not our tetrahedron. The tetrahedron that we have to form, however, inside of this cube, this figure, the goal is to create one that does not share or overlap the faces of the cube. And you might be thinking, how do we do this? Actually, fairly simple. So here we're going to see the shape slowly take form within this cube. Now, if you're paying attention, you see that the faces within this tetrahedron, they are not overlapping or using the faces of the cube to create themselves. It's almost like having a cube and then having a figure inside, but the faces of the 2 figures are not aligned with each other. Whereas the one we see here is largely doing that exactly, taking up most of the faces of the cubes. So we see the one on top is what we're looking for, whereas the one on the bottom is not. So the one on top is going to be our answer, and it is the more properly constructed tetrahedron. Now, question 6 is we have to build Schlegel diagrams for the tetrahedron, the octahedron, and the icosahedron. Now, what exactly are these? Well, like in the previous question, in this case, the tetrahedron is going to be a solid figure with 4 plane faces. And so we are going to label out the names. Now, the tetrahedron is going to be this. Now, you see a triangle with 3 lines in it. But if you imagine it as a 3-dimensional figure, like we just did with our previous question, you can see it's more like a pyramid. There are 1, 2, 3 faces, and then there is the 4th beneath the entire figure. Now, an octahedron, we understand octa meaning 8, so it's going to be an 8-plane faced figure. And it's going to be a lot more complex looking than the tetrahedron. But if you take count, we have 1, 2, 3, 4, 5, 6, 7, and then 8 on the bottom. And an icosahedron is a solid figure with 20 plane faces. So it's going to be a bit more difficult to create, only because it has so many faces. But if you're paying attention and are simply basing them off the previous models, you can create the 19 faces required and the 20th on the bottom. And that concludes our lesson for today. Thank you guys so much for joining me with this lesson. I hope I explained geometric figures well enough. I hope that you guys came away from this learning something. Please, please, please make sure you study. I will see you guys on the next lesson. As always, stay wonderful.